and one common approach in the case of multiplying polynomials, especially if the polynomials are two-term expressions. Okay, we have what is regarded as the FOIL method. And FOIL is going to be an acronym for first, outer, inner, and last. Okay, so just for the general representation of the FOIL method, okay, you might have a couple of polynomials, and they are, in the general case, often presented in the guise of a couple of two-term or binomial expressions, where we have the quantity of a plus b times the quantity of c plus d. And if you're looking at multiplying out, okay, you have, like in the case of the first product, you have a and c will be multiplied together. And then you have the outside terms, you have a and d. In other words, those terms most distant from each other. And the next product will be multiplying b and c. And then we have the last product will be multiplying the last terms from what we have in the case of utilizing the FOIL. Okay, let's see, just check something here. Okay, so you have AC plus AD plus BC plus B times D. And looking at what we have with algebraic expressions. So if we're looking at let's say we have a couple of binomial expressions with x plus 7 and x plus 9. And if we look at multiplying together, okay, so you have like a and c are represented by the x's. So for a times c, we have x times x. And we have for a times d, okay, so a is at x, d we have at 9. And we have for b times c. So b is at 7, c is going to be the second x that appears. And we have for the last product b times d. Okay, so we have 7 times 9. So looking at what we have upon multiplying. So we have x times x. So this will be x squared. We have x times 9. Okay, so this will be 9x. And we have 7 times x, so this will be 7x. And 7 times 9 is going to be 63. Okay, and just kind of going back. Okay, so again, FOIL, we have an acronym for first, outer, inner, and last. And looking at what we have upon taking the products. Okay, so the first term we had to be x squared, and there's no other term that consists of x squared. Okay, so this is going to be a unique term in the set. Now for the middle two terms, we have 9x and 7x, and those are what are referred to as like terms. And like terms are those items that can be added or subtracted and consolidated into a simplified expression. Okay, so you have the case of 9x plus 7x. So this will be at 16x. And again, we have a 7 times 9 at 63. 63 is the only constant. So you have for the results we had the product of x plus 7 and x plus 9 to end up at x squared plus 16x plus 63. Right. And also, if you have, we say we have different letters. If I have something like, we'll say that we have I'll say another combination case. See, we have 3t minus 4w multiplied by 2t plus 3w. Okay, so in this case, okay, we have two distinct variables with t and w, whereas before we had just the letter x. So if I were to take the FOIL out, now if you already see the products ahead of time, that's fine. Again, I'm just going to kind of take this step by step for now. So for the first product, we're involving the first terms 3t and 2t. Outside products, okay, we have 3t and 3w. And for what we have on the inside, okay, so you have negative 4w times 2t then for the last product case, we have negative 4w times 3w. And again, if you're acquainted enough with the determination of the products before writing out the detailed initial step, that's fine. Just make sure that you don't have the wrong degrees or the wrong variables. Okay, so for the first product, we have 3t times 2t. So you got 3 times 2 is 6t times t becomes t squared. So you have 6t squared. All right, now for 3t times 3w. Okay, got 3 times 3 is 9. And you can put the order of the variables in any fashion. And I'm just going to put these in alphabetical arrangement. Okay, so we'll have 9tw. Then for the next, I have negative 4w times 2t. Negative times a positive is a negative. So I got minus 8. And you have w times t. I can rearrange in alphabetical order where the inside term product comes out to negative 8tw. And then for the last term, we've got negative 4w times 3w. So this will be negative 12w squared. And so for what we have now, okay, the first term we have 6t squared, and that is the only term that is consisting of t squared. Now for, again, like 9x and 7x, we had the middle two terms to also be like terms because they both contain the letters t and w, where both t and w are each of first degree. So I can just combine these terms together. So 9tw minus 8tw comes out to 1tw or just tw. And we have for the last term, this is just going to be minus 12w squared. Okay. Now, a special case of what we have regarding taking the FOIL method. If we have, let's say, okay, let's say if we have 3u minus 2v squared. Okay, notice we have a single expression, but we have the raised power expressed, okay, where we have the second degree. So if I were to translate this in terms of multiplication along the lines of where I started out with the prior two examples, okay, that number 2 means that you're going to have 3u minus 2v to repeat. In other words, that 2 signifies the number of appearances of 3u minus 2v. In other words, like if I had 3u minus 2v to the third, it would be 3u minus 2v times itself times itself. And so looking at what we have in the case of the FOIL, okay, so we have for the first items, okay, so I have 3u times itself. And for the outside terms, I have 3u times negative 2v. And I have plus negative 2v times 3u. And for the last product, okay, notice that we had the second terms from each binomial will be negatives. So I have negative 2v times itself. So looking at what we have throughout the process. Okay, so you have 3u times 3u. So this will be 9u squared. And for the outside product, we have 3u times negative 2v. So we have a negative 6uv. And negative 2v times 3u is also going to yield negative 6uv. And for the last product, for negative 2v times itself, okay, so it's going to be a plus 4z, not 4z, but 4v squared. Okay. And so looking at what we have in the result, okay, we have 9u squared, and negative 6uv and a negative 6uv. Those will combine to negative 12uv. And finally, we have plus 4v squared. And for what we have in effect, okay, since I squared out 3u minus 2v and had, upon yielding 9u squared minus 12uv plus 4v squared, can have a special case in this particular example. And this is going to be, in the case of the output, this is going to be what we have in the case of what is referred to as a squared trinomial. So these are cases of what we have upon applying the general case of the FOIL method. And there's another way of multiplying polynomials, and it's also like another version of the FOIL method, and you probably have heard of this as the box method. And if you've never heard of it, that's fine, but in the case of the other approach, this is going to be what is referred to as the geometric FOIL method. So what you're going to have here is the same type of work, but just retooling it and displaying the terms in row and column formation. So you have like A plus B times the quantity of C plus D So we have here, okay, so you have A plus B, C plus D, okay, and so you have just with the corresponding portions, if we look column by column, starting from the top, okay, so you have in the first cell, you have A times C, then going down, we have plus AD, next column, starting at the top once again, we have plus B times C. And for the last section, okay, we have the last products. You know, the first, outer, inner, and last. You have in this order, so you have AC plus AD. You have plus BC plus BD. And say if you're looking at solving by the geometric FOIL method, but you're still going to be solving by the FOIL method. It doesn't change the output at all. And we'll take as an example, we'll say we have let's say we have 4W plus 3Y times the quantity of (2W) minus 10Y. So if I put these terms in row and column formation, and operationally, it does not matter which binomial you have as the row headings and which you have as the column headings. I kind of go with the traditional arrangement of having the first binomial to make up the column headings and the second the row headings. So we have 4W and plus 3Y. And we have for the second binomial, we have at the top row we have 2W. And for the second row heading, we have minus 10Y. Okay, so looking at solving, looking at the corresponding portions here. So we got for the first product, we're entering the result of 4W times 2W. So in this case, this will be 8W squared. And if we go down the first column, we got 4W times negative 10Y. So we have a negative product in this case. So we have minus 40 WY. And for the second column, we have for that product, we have plus 6 WY. And in the case of the last product, we have minus 30 Y squared. Okay. And so looking at what we have for the outputs, okay, so we have 8W squared minus 40 WY. Here we have plus 6 WY. We have minus 30y squared. Okay, so you have 8w squared. The only term exclusively in w squared. Now the middle two terms, we have first degree in both w and y. So we have negative 40 plus 6 wy, so this will be minus 34 wy. And we have minus 30y squared. Okay, and we'll be soon looking into operations of kind of shifting gears and taking things in reverse. I'll tell you what, just for the next few moments. Okay, let's see what we get. And you can use either the regular or the geometric foil. Just a couple of items here. Let's see what we get whenever we multiply. So you have x plus 2b times the quantity of x minus 2b. And also, in the case of what we have with with 3w plus 4y raised to the second. So for the next few moments, okay, let's see what results we get when multiplying out these expressions. Okay, just a few things here. Okay, for first item we have x plus 2b multiplied by the quantity of x minus 2b. And for the second item, okay, we're looking at the square of 3w plus 4y, and the 2 indicates that if you were to express solely in terms of multiplication, okay, we're looking at 3w plus 4y times itself. Okay, and regardless of whether you take the regular or the geometric foil approach, your output is still going to be the same. Okay, so for what we have in the case of the first item, for x plus 2b times the quantity of x minus 2b, and we'll go with the regular foil on this one. Okay, so we're looking at x times x. And for the outer terms, okay, we have x times negative 2b. And for the inside, we have 2b times x. And for the last product, we have 2b and negative 2b. So looking at what we have among the products. Okay, so we have x times x. Okay, so this is going to yield x squared. And then we have for the next product, we have x times negative 2b. And if I take the product and arrange the letters in alphabetical order, okay, so we're going to have a negative 2bx followed by what's going to be a positive 2bx. And for the last product, okay, this is going to be a negative 4b squared. And if you notice, in the case of the activity, okay, you have x squared and for what we have in the case of negative 2bx and 2bx, those are like terms. and the coefficients happen to be additive inverses. And what do additive inverses do? Well, they're going to end up canceling each other. So these are going to go out. So we're not going to have a bx term in the output. And left over, we have negative 4b squared. And this is going to be a case of what will be referred to as a difference of squares. And the general formula for the difference of squares is if you got, say if your first binomial is a plus b, and you got almost the same thing except you have subtracting and foiling out, this is going to basically go to a squared minus b squared. And that is just in the general case. Okay, so there's not like a first order middle term. And this is one of those special cases. Now, for what we have in the case of the second item, we have 3w plus 4y squared, or we have 3w plus 4y times itself. And we'll just go with the geometric FOIL route or pathway on this one. Okay, so we have the same row and column headings. Okay, so looking at multiplying the corresponding portions. So we got 3w times itself. This will be 9w squared. Next part, you have 3 times 4 is 12, and attaching the variables. We got wy, so we got plus 12wy, and for the next product, same thing here. 3 times 4 is 12, and you have from the terms you have w and y. And for the last product, you have 4 times 4 is 16, and y times y becomes y squared. And just taking the terms from the respective cells. You have 9w squared plus 12wy plus 12wy plus 16y squared and for what we have here, okay, so you got 9w squared. And got like terms identical, they will add instead of canceling. So you have 24wy. And then we have for the last product, we have 16y squared. So the output here is going to be the trinomial 9w squared plus 24wy plus 16y squared. Okay. All right, so again, I had mentioned that there are other operations that we'll be looking at in terms of transitioning and looking at things through the lens of working in reverse. And what I mean by this, especially like in the case of the FOIL method, you're taking 2 items, or at least 2 items, multiplying to get to the output. Now for what I'm going to have in the reverse cases, where you're going to have the output given and you're going to be asking what the inputs are that will be multiplying. And this will be through the prism of referring to what is regarded as factoring polynomials. in a lot of cases, this is going to be, not all cases, but in these particular cases, we'll be looking at essentially taking the FOIL method in reverse. Okay, and let's say that if you're looking at factoring the following. Let's say we have for the first item, okay, we'll say we have x squared plus 7x plus 12. All right, now for x squared plus 7x plus 12. Okay, and notice that going back to when we were looking into, let's say like this example, we have like x squared, okay, originated from taking x times x. And guess what? Working in reverse. Okay, so for x squared, the term that will be multiplying itself to get to x squared is going to be x. So for x squared, this factors out to x and x. Now for the factors, okay, we're going to be looking at the coefficients of the middle term as well as the last term. So we got 7 and 12. And in terms of the follow through, okay, you'll be looking or asking yourself, what are two numbers that will multiply into 12 and at the same time add up to 7? Okay, and here, okay, we got a positive product and a positive sum, so both numbers will have to be positive. And so for those numbers that multiply into 12 and add up to 7, and that is going to be at 4 and 3. And it doesn't matter what order you place the factors. If you have x plus 3 out in front and to be followed by x plus 4, that is also correct. Now let's say if you have a case, and so starting out with x squared, and let's say we have x squared so we have x squared plus 10x minus 24. And again, so you have x squared. So this is factorable to x and x. Now we have, with the coefficients this time around, we have a positive 10 and a negative 24. And for negative 24, you're looking at factors that will multiply into negative 24, but that will combine in terms of adding and subtracting, where the sum or difference will end up on the plus side at 10. Okay, so we have a plus factor and a minus factor. Okay, and since we have a plus 10 at the end, we will have more weight given to the addition than to the subtraction. And now for negative 24, if you think about it, okay, you have all kinds of combinations. So like for negative 24, you have like 24 times negative 1, 12 times negative 2, 8 times negative 3. If I were to add together, like 24 plus negative 1 is 23, 12 and negative 2 is 10, 8 plus negative 3 is 5, 6 plus negative 4 is 2. But I'm looking for that combination where the sum is going to be on the plus side at 10. And this happens to be 12 and negative 2. So we have for that output, we have x plus 12 and x minus 2. And just like the combinations that I just put up, these will especially apply to situations where you might have a term other than just plain x squared. But for what we have right now, if I have, let's say, x squared plus So I have x squared plus 20x plus 100. Okay, so you have a factorable trinomial expression. Again, the leading term we still have with x squared. Okay, so x squared will factor out to x and x. Now for numbers that will multiply into 100 and add up to 20, okay, this can be one combination. And you have like with the numbers each at 10. So you have like 10 times 10 is 100. And 10 plus 10 comes out to 20. And if you notice, okay, again, you can always double check. X times x is x squared. Outside product we have x times 10 becomes 10x. Inside product we have at 10x, and combining we have at 20x. And the last product we have at 100. And notice we have repetition of x plus 10. I know especially in ALEKS, if you have a repeating factor, like in case of x plus 10, you want to consolidate this. We have that expression raised to the degree that matches with the number of appearances. In this case, we will have x plus 10 raised to the second. So again, this, which we have here, again, is another case of squared trinomial. Okay, if you notice, okay, so far we've had the term in the middle, okay, to be positive. And say if I were to change the weights here, and let's say that if I have, let's say x squared minus 3x minus 40. So you have x squared minus 3x minus 40. Okay, in the case of x squared minus 3x minus 40. So again, x squared we have factoring out to x and x. Okay, and for minus 40, okay, we're looking at factors of negative 40 whose sum or difference will be at negative 3. So more weight will be given to the subtraction than to the addition. Okay. So think of like for negative 40, you know, like combinations, have like negative 40 and 1, negative 20 and 2, 3 won't go into it, but 4 will. And just for the respective sums. Okay, so you have like negative 40 times 1 is negative 40, but in terms of adding, negative 40 plus 1 is negative 39. Negative 20 plus 2 is negative 18. Negative 10 plus 4 is negative 6. And negative 8 plus 5 is negative 3. And so that is going to be the combination we're looking at. And so to fill in, okay, so we have for the positive and the negative factors, okay, so more weight will be given to the subtraction. So we have x minus 8. Now on the plus side we have x plus 5. And sort of staying on this page, if I had, let's say, x squared minus 18x minus 40. Okay, so from x squared, I still have x and x. Now the factors of negative 40, whose sum or difference will be at negative 18. This will be with negative 20 and 2. Okay, and so in this case, I'll just put the negative 20 out to the front. So the binomial factors will be x minus 20 and x plus 2. All right. So these two cases are where we have the middle term to be negative. Okay, but let's say that if I have just two terms in factoring. Okay, say if I have x squared minus 64. Okay, so I have x squared minus 64. And the way that you could look at this, okay, we don't have an x term. And if I were to display it where I might have the variable x to appear in any capacity, it'd be like x squared plus 0x minus 64. So from x squared I have x and x. Now for negative 64, okay, so to get this to where the outside and inside products will combine to 0, I'm going to have the same weights applied for the adding and the subtracting. So two numbers of equal weight in terms of positivity and negativity that will multiply to negative 64. Well, those numbers will be 8 and negative 8. And this is going to be another case of what we have with a difference of squares. Right. And so just in the case of factoring, let's see what we get in the case of, so we have x squared minus 36. And x squared plus 14x plus 49. Now say we have x squared minus 10x plus 24. Okay, so for the next few moments, let's see what factors we get for these polynomials. Okay, for each of these expressions, okay, so the leading term is x squared, and throughout okay, we have in each of the factors, okay, we'll have x. But again, we're going to have some trinomials that will start out with items other than just x squared, and not just a different letter, but also a different coefficient. Okay, so for what we have in the case of x squared minus 36, okay, notice we don't have a first order x term, and this is a case of what we have with the difference of squares. So for negative 36, you're looking at factoring out to a positive and negative set of factors that will have the same absolute value, that is same distance away from 0. So we'll be adding and subtracting the same amounts, and that times itself, that will give you negative 36 will be a positive 6, as well as negative 6. So the factorization will be x plus 6 and x minus 6. Alright, now in the case of x squared plus 14x plus 49, okay, so x squared we have going to x and x, and factors of 49 that will add up to 14. Now for, let's say, the natural number factors of 49, you have like 49 and 1. However, 49 and 1 add up to 50, and the other natural number combination is going to be 7 and 7. And guess what? 7 times 7 is 49. 7 plus 7 is going to be 14. So here we're going to have the quantity of x plus 7 times itself, and since we have a repeat of this factor, again, x squared plus 14x plus 49 is going to be another case of what we have with a square trinomial. All right, and then we have in the third case, right? So this one is a bit distinct from the other examples, for we have included with the fact that the second term is negative, we had the constant at the end to be positive. Okay, and we're looking at, in this case, you have the constant at the end of the trinomial to be a positive 24. And we're looking at those factors that will add up to negative 10. And the only way for factors to end up multiplying into a positive, especially when paired up, is that either both factors had to be positive or they had to both be negative. And when thinking about factors of 24 that are negative, you might be thinking of items like negative 24 and negative 1, or negative 12 and negative 2, or like negative 8 and negative 3, and even possibly negative 6 and negative 4. And in terms of if you were to add up these combinations, so each of the pairings will multiply out to 24, but in terms of adding, negative 24 and negative 1 will be negative 25. And for the second pairing, negative 12 and negative 2 will be negative 14. And negative 8 and negative 3 will be negative 11. And negative 6 and negative 4 will add up to negative 10. Okay, so this will be the item we are looking for. And so for the pair here, we're looking at minus 6 and minus 4. So x squared minus 10x plus 24 factors out to x minus 6 and x minus 4. And then just kind of throwing this in. If I had x squared minus 14x plus 24, okay, we would have x squared going to x and x, and the factors of 24 that will add up to negative 14. And I have this combination up where we have negative 2 and negative 12. So one factor is going to rest at x minus 12, while the other one is at x minus 2. So we have another factorization example where the leading term is x squared. Okay, now for what we have for trinomials where the leading term has a higher coefficient, and many such items will involve what is regarded as factoring by grouping. And say if you were to factor the following. And we'll say that we have factoring, let's say we have I'll go with a different number at the front. We'll just say that we have factoring 3x squared plus 14x plus 8. Now with the coefficients being low enough, okay, you might be able to get to the result from doing a bit of guessing and using the FOIL method. But if we go with the grouping approach, okay, so we have 3x squared plus 14x plus 8. Now setting up what will be regarded as factoring by grouping. Okay, what you're going to look at this time around. Okay, now Now 3x squared, okay, it's not going to be an automatic like going to x and x. Okay, but we are going to have a couple of first order x terms, but you're going to have a different coefficient since we're factoring out 3x squared as opposed to just 3x squared as opposed to just x squared. So in the case of the lead up to factoring by grouping, we can look at the first and the last coefficients, which in this case will be 3 and 8. And you're going to multiply together. So the first and last coefficients, you have 3 times 8. So that is going to be 24. Okay, so involving the first and the last numbers in this trio. Now where 14 is going to come in, I'll be looking at factors of 24 that will add up to 14. And for what we worked with, okay, now we took 3 and 8. However, 3 and 8 will add up to 11. Okay. And if we go with another combination, okay, so we have like 3 times 8 is 24. However, 3 plus 8 is 11. And if we go with another combination, it doesn't matter which order you place those. Let's say we have 12 and 2. 12 times 2 is 24, and guess what? 12 plus 2 is 14. And in terms of how we're going to involve 12 and 2, we're going to reference the middle term of this trinomial. And we're going to take 12 and 2 and form x terms upon splitting up the 14x. So for 3x squared is 14x plus 8. Okay, so for right now 3x squared is untouched, but for 14x this will be split up into x terms with the coefficients of 12 and 2, and it does not matter which order the terms will come. And we say we have plus 12x followed by 2x, and we have plus 8 at the end. So I've split up the middle term. Now where the grouping comes in, I'm going to take the first two terms and combine. So I have 3x squared plus 12x, pair those up, and we have the middle operation. We have addition. And I'm going to group together the last two terms. So we have the quantity of 2x plus 8. All right. Now, we'll go through another round of factoring in the sense of determining the greatest common factor of each pairing. Now for 3x squared plus 12x, looking at it by itself. Okay, for 3x squared plus 12x, okay, now 3 is the number that will go into itself and 12. And if you notice, we have the letter x present in both of these terms. So the highest term that will go into both 3x squared and 12x is going to be 3x itself. Okay, and 3x into 3x squared is going to yield x, and 3x into 12x is going to be 4. Now for 2x plus 8, the greatest common factor is only going to be a number, since 8 is a constant, and the highest number that will go into the coefficient 2 and the number 8 itself, that is going to be limited to the number 2. And 2 into 2x plus 8 is going to be the quantity of x plus 4. And if you notice, upon splitting up 14x and having pairs of binomials and drawing out the greatest common factor. Notice we have x plus 4 to be common factors to both pairs, and in consolidating, okay, one factor of this trinomial would be the factor that is shared in common, which in this case is going to be x plus 4 and the other factor of this original trinomial will come from putting together the outside terms, namely the greatest common factor and the linking operation in this case, which we have to be addition. In this case we have 3x plus 2 from the outside, and those will be linked together as the other factor of this trinomial. Okay, so we can declare 3x squared plus 14x plus 8 is equal to the quantity of x plus 4 times that of 3x plus 2. And you can always go back and check what we have here, like x times 3x is 3x squared, x times 2 is 2x, 4 times 3x is 12x, and 2x plus 12x makes 14x, and 4 times 2 is 8. All right, and let's say that if we have a case here where the numbers will be somewhat raised, okay, and tell you what, let's say if you have factoring, now say we have factoring 10x squared plus, let's see, for right now I'm just going to leave what we have in terms of adding. Now we just kind of hold off for right now what we have in terms of any negative terms that appear. So you got 10x squared plus 21x plus 8. Now, for the first example, when we had 3x squared plus 14x plus 8, okay, now 3x squared, okay, the combination would be like 3x and 8 could be like, could have been plus 1 plus 8, plus 2 plus 4, plus 4 plus 2, or plus 8 plus 1. But the combination had to be x plus 4 and 3x plus 2. Now for 10x squared plus 21x plus 8, now 10x squared, this can go in all kinds of directions if you were to try guessing, and it might take a long time to find the right combination. For 10x squared, it could be 10x and x, 5x and 2x, 2x and 5x, x and 10x, and 8. No better a situation. It could be 8 and 1, 1 and 8, 4 and 2, 2 and 4. And for what we have in the case of taking the factoring by grouping approach, this can take a lot of unnecessary guesswork out of the picture. And if we kind of repeat the procedure of multiplying the first and the last coefficients, so we've got 10 is the first, and 8 is the second. So we have 10 times 8 is 80. So 10 times 8 is 80. And if we're looking at factors of the product, that will add up to 21. So we start out with 10 and 8. And 10 times 8 is 80. However, 10 plus 8 is 18. Okay, and for the next possible combination, okay, you have 11 won't go into it, 12 won't go into it, 13 will not, 14 still not divisible into 80, nor is 15. But in the case of 16 will go into 80 5 times. And 16 plus 5 is 21. And this, again, matches up with the middle term coefficient. So you're going to have x terms with the coefficients 16 and 5 that will be used to split up the 21x. And for what we have upon creating the follow-through on this one. And your combination could be with 5 in the front and 16 to follow, but I'll just do it as it appears. So 21x will be formed by 16, or split up in the formation where we have 16x plus 5x. And looking at grouping, okay, so you have 10x squared plus 16x as the first pair. Now we've got the middle operation, again, to be addition. And go ahead and put in parentheses 5x plus 8. Okay, so this is what we have in the pairing. Now for the first binomial, we have 10x squared plus 16x. So we have variable terms in the letter x. So we're going to have a greatest common factor to consist of x. And for the greatest common factor, okay, the highest number divisible into both 10 and 16, okay, that's going to be 2. And for 10x squared plus 16x, okay, that is going to be 2x. Okay, so 2x is the greatest common factor, and 2x into 10x squared is going to be 5x, and 2x into 16x, okay, so that is going to be at 8. Bring down the addition. Now for 5x plus 8, we're going to have just a constant for the greatest common factor, and the highest number divisible into both 5 and 8, since 5 is an odd number and it's prime, and we have the number 8, the greatest common factor is only going to be 1. And 1 into 5x plus 8 is going to be 5x plus 8. And for the factorization of 10x squared plus 21x plus 8, okay, after the groupings, okay, we have the common binomial factor. At 5x plus 8, and joining this with the other set of terms, and this would be where we have combining or consolidating within parentheses the outside terms in operation. Okay, we got 2x plus 1. So we're going to have, in effect, for 10x squared, that's 21x plus 8. Okay, it's going to be equal to 5x plus 8 times the quantity of 2x plus 1. And you can always go back and check. Okay, so we have with the first terms, got 5x and 2x multiplied out with 10x squared. Outside product is going to be 5x. Inside product, we have 8 times 2x is 16x. 5x plus 16x is 21x. And the last product comes out to 8.